Okay, nag-record na. So, mo to ang stability will determine whether a structure is stable or not. And na basis, di ta pwede na tagna-tagnaon lang sad na to. Kaya na may uban complicated good. Okay. While ang determinacy is i-determine na to ang structure whether determinate siya or indeterminate. And I think na mo idea ani kaysa kaysa mechanics of deformable bodies, naka-discuss naman ta about indeterminate o ang determinate pod. So, it has something to do with unknowns and equations, relationship nila. Diba? Okay. So, sorry. Sipyat, no? A structure refers to a system of connected parts used to support a load. So, important examples related to civil engineering include buildings. Kini, no? So, ayos aning bridge na edit mo ni. So, example of a building, di ba? This one. Siguro kailangan mo ay. Muna siyang Burj Khalifa located sa Dubai. And few info sa Burj Khalifa, 828 meters high. Almost 1 kilometer, di ba? Taas kayo. And it has 162 stories. So imagine na, no? So, kining structure, makita mo, dari niya, it's a system of connected parts, na beams, columns, footing, etc. Na siya. Kini kaduha, bridge siya. So, dagan man kasi sa bridge, natay katawag suspension bridge. So, kini siya, suspension bridge siya. So, ang suspension bridge, it is a type of bridge which has cables between towers. Kini, no? Cable ka na yun. Cable na siya. Ang tawag na suspension cable. And then, nasa tayo, vertical na suspender cable kini mga vertical sa di ba? Ang tawag na niya kay hangers. So, na sila gamit sa structure bale. And ang mga suspension bridges usually na siya sa mga kini mga large body of water ba kay long span mo siya. Long span ba tapos pwede siya i-build na habog kayo. And kung long span man god, kung tanawon nimo ning tulay, pag long span, possible nga excessive ang deflection kay bugat mo kayo. So to counter that one, para ma-counter nimo ang excessive na deflection niya, mo ni siya. Mo ni naata sa suspension cable para i-carry niya ang load. Anyway, ma-discuss man natay topic about cables. Then dito may balaran siya gamitan na niya. Okay? Pero kini nga model, kini nga picture, this Akashi Kaikyo Bridge in Japan. Mo pa na siya ang pinaka longest bridge. Bali tulo na siya ka span, bali ang kuha na niya, very impressive ni siya kay aside na it's very long, it was designed to withstand an earthquake up to a magnitude of 8.5. So, inana na siya ka pusga na tulay. So, ang total gid span niya gikan sa isa ka location paingon sa Picas is almost 4 kilometers, 3.9 something. Ayan na. Pero kining pinaka-main yun niya, main na span, kanang agianan sa mga barko, it's almost 2 kilometers. So imagine, 1.9 basta. Almost 2 kilometers ang main span niya. So bugat kaayo ba? O unsaon pag support sa loads niya. So ang suspension cable na bahala diya together with kining hangers o nanay mga loads nga gi-carry niya. This one siguro kailan mo Be, kisay mo pakichat da type da o kailan ba mo na. Diba? Plus points ang makatubag. In a count of 10. 1, 2, 3, 4, 5, 6. Wrong. London Bridge is falling down, falling down, falling down. Wrong. Misconception na. Di na mao ang London Bridge. Although the bridge is located in London. Okay, correct. Tower Bridge ang tawagan Oh. Although this is located in London, pero dili siya mao ang London Bridge. Lay ang London Bridge. Ang tawag niya is Tower Bridge. Okay, so as you can see, if we focus on this bridge, kini siya combined bascule and suspension bridge. So kini ang tawag niya ni bascule. Pasabot sa bascule ay it is a type of bridge with a pivoting section kini o ganing si pikas pod that is raised and lowered using counterweights. So ang purpose ani niya is at certain time of the day, pag namuagi ng mga barko, i-open siya. And kining tower bridge, kining bascule niya, pwede siya ma-rotate nimo up to 83 degrees from the horizontal. Yan. So pag wala na barko, mag-close mo ni siya. So muna siya once ma-open niya, dili kalusot ni kuan mga sakyanan. Tapos mga tao, dili po kaagi. So musaka sila dere na walkway, di sila agi. Di sa taas. Similar ni sa purpose sa atong gitan-aw ganina. Bascule ba? Dual purpose nga bridge ba? So kini siya. Kini siya lang is mga vehicle sa moagi. Tapos barko dayon. Katong sa video ko ganina, train ang moagi ato o barko dayon. So kung walay train na to, i-open to para makaagi itong gagmay nga mga boats. Pero kung wala, sadaan to, every time na ay kuan, may mga gina-train and closes. Okay. And then, including buildings, bridges, and towers. Okay, the last picture is kuan kining well-known by now. It's Eiffel Tower in Paris, France. The tower is 324 meters high o meters tall. Abogayo, tulo sa ka-level. So bale ang basahon mo sa Wikipedia, na mga restaurant ning first level o second level. Sa third level wala. So kung bisita ka nya kay kwarta, atara ka third level magwan, puyo. Pero listen sa yun kay ang paingon mo either stairway or using a lift. So kung kay kwarta, kat ka diri sa kilid. Joke lang. Anyway, examples ano sila? Examples sila sa structures. Aside ani na pa uban po. So, when designing a structure to serve a specified function for public use, the engineer must account for its safety. Number one, no? Number one priority. Dapat safe siya. Aesthetics, kanang tsada sa tanahon. Di ba? O, aesthetics and then serviceability. O, base, no? After pila ka months, o, di na magamit. Di ba? So, mo na concern sa engineer. Puhon, kung engineer na mo, and you want to be a designer, and you have to consider this one. While taking into consideration economic and environmental constraints. Dapat ang design mo economical pod. Dili sad nang like pareha ng mga daan nga buildings nga circular ang poste. Mura pareha kada ko atong poste nga gibungkag ni Samson, di ba? And as you can see, kanang mga urban buildings karon gagmay na lang ng mga poste, di ba? Okay, kuan man na siya, gi-maximize man ang kuan. So dapat economical imong cross-sections and everything. Dimensions nimo. Environmental constraints also. This design process is both creative and technical and requires a fundamental knowledge of material properties and the laws of mechanics which govern material response. So, dapat kuan ka ba kini kung mag-design ka, dapat kabalo ka sa material nga pinaka-best nga gamiton. Okay? And not at all times na concrete siya, pwede ka steel and everything. So, once a preliminary design of a structure is proposed, the structure must then be analyzed to ensure that it has the required stiffness and strength. Muna na yun. So, there is analysis, di na tayo ma-apply yung matunanan. And then to analyze a structure properly, certain idealizations must be made as to how the members are supported and connected together. Di na dayon mga kwan. Di na dayon ma-apply yung mga katunan there. Kaya ikaw naman na mag-decide. So, gusto niyong mahitabo. The loadings are determined from codes and local specifications. Naman tayo mga kwan sa building codes naman dito. Pilay live load, di na natin. So, i-appeal to nimo sa imong kwan. I-consider. And the forces in the members and their displacements are found using the theory of structural analysis. Their displacement. Like for example, sa beams, pag mag-design ka, aside sa na-strength nga gina-consider, ginalimit po ang deflection. Di ba pwede nga i-allow nimo sa nga dagko displacement. So, like 1/360 sa span. So, kung pila span nimo, i-divide nimo, kaya mo to allowed na maximum deflection niya. I-appeal to siya sa consideration sa design dayon. Ingin na. So daghan man criteria gamiton. And mamili na din ka unsa dito ang pinaka-safe. Classification of structures. It is important for a structural engineer to recognize the various types of elements composing a structure and to be able to classify structures as to their form and function. Some of the more common elements from which structures are composed are as follows. Ano sila? Tie rods. Like ng mga electronic towers, saka ng mga telecommunications ba? So, para kusga na siya, ang mga supports na mga tie rods, cables, yan ba? Uguban pa. So, structural members subjected to a tensile force are often referred to as tie rods or bracing struts. Due to the nature of this load, these members are rather slender and are often chosen from rods, bars, angles, or channels. Okay, ang design nila ni tension man. Mga tie rods. Next is skinny beam. Part ni sa master ng morning beam. Beams are usually straight horizontal members used primarily to carry vertical loads. Quite often, they are classified according to the way they are supported. Simple supported, cantilevered, fixed supported, or restrained beam ang tawag, continuous beam na yun. Kanang more than one span ba? Continuous beam ang tawag. In particular, when the cross-section varies, the beam is referred to as tapered. Usually, kanang tapered sa mga cantilever na siya. Bali, mas dako ang cross-section dire sa support, mas gamay dire. Okay, zero ang kanang movement na naman, pinakadako ang movement dire. So, dapat mas dako ang cross-section dire. Kaysa dire free in. Tapered ang tawagan na. Beam across sections may also be built up. Built up like sa mga steel beam na ay I-beam tapos na ay plate sa ibabaw, built up na. Gina-weld or bolted, depende. Sa steel design na siya. Okay. Beams across sections may also be built up by adding plates to either top or bottom. Yung inanan. Pwede sa ibabaw, pwede pa sa obus. Beams are primarily designed to resist bending moments. Next, columns. Okay. Members that are generally vertical and resist axial compressive loads are referred to as columns. So, kung mag-consider ka og simple na frame no, gaya frame ba? Vertical, horizontal, vertical. Kining load sa kining load nga vertical nimo, mura ra sa og reaction sa beam ba? Kato reaction sa imong beam, it will serve as compressive force sa imong column there. Marag inginana. Tubes and wide flange cross sections are often used for metal columns, and circular and square cross sections with reinforcing rods are used for those made of concrete. Occasionally, columns are subjected to both an axial load and a bending moment. Kini, no? Pero, usually, magyapon sa ato. Nagyapon sa pero kasagara kita na design. These members are referred to as beam columns. Yeah. The combination of structural elements and the materials from which they are composed is referred to as a structural system. Combination na? So nakay-column, nakay-beam, nakay-column, nakay-beam, nakay-column. Ang tawag na frame. So it's a combination of structural elements. Each system is constructed of one or more of the four basic types of structures. Ranked in order of complexity of the force analysis, they are as follows. Trusses. So, Ready ka putol ha. I only have 1 minute left. So, ako na yung stop and then send out to